Hello my dear students, I hope you all are fine. My dear students, today we are in lecture number 26 of standard 11 and we have studied the momentum and Newton's second law. We have done few questions, we will continue today, but before that, calculation of any new type of numerical which is based on Newton's second law, we will understand conservation of momentum, the law of conservation of linear momentum. I will just discuss very simple question on the basis of this one, and then I will include a video clip to understand the application of conservation of momentum. And then after, we will conclude the class with the calculation of numerical problems, which is of inclined plane. Okay, my dear students, so let's start today's lecture number 26. I am B S Pandey here. Actually, we are studying Newton's laws of motion, that is NLM, very important chapter of standard 11. Okay, so today we are going to start our lecture with the principle of conservation of linear momentum. According to this conservation principle of momentum, my dear student, as we have studied in standard 9 also, but here if you are considering a isolated system in which there are number of bodies are present, okay, number of bodies are present, and individual bodies in that system, if changes their momentum, then of course the individual momentum is changing. But according to this principle, if there is no external forces acting from outside on the system, okay, all the forces are acting by the individual bodies, then in that case the total momentum of the system will be conserved, that is remain constant. If it was 100, the linear momentum, it was 100, okay, before any particular action, then after action of the individual bodies inside the system, the total momentum remain 100. This is as much as simple the conservation of linear momentum. Okay, the total momentum, if the bodies are getting collide with each other inside the system, then the total momentum before collision and total momentum, linear momentum after collision must be conserved. We will correlate this conservation of angular momentum in our rotation chapter also. Okay, so as we have discussed, if for any system, suppose in a system here the body, it is this is a car A which is moving with velocity UA, okay, and the car B, it is moving with the velocity UB. The masses are there, MA and MB. If suppose a scenario, a condition, if this UB is smaller than UA, what will happen? There must be some collision. Okay, so this is the case of before collision. Before collision. Actually, due to this condition, if this is moving faster, of course it will collide with the second car, and after collision, what will happen? The two cars, if get separated, the same thing you will recall in the chapter that collision suppose its velocity becomes VA and its velocity becomes VB. If they separated after collision, why VB is greater than VA. After collision, there are number of possibilities. Remember, we are not going for that possibility. We are not going to discuss all that possibility. We will discuss in collision chapter here. But we have considered VA, that is the second car, that is car B, gets separated after collision with this car A. Okay. Now, this is the case of after collision. After collision. Okay. And this was the condition for collision. Now, here before collision, the total momentum of the system, my dear student, we can write the initial momentum before collision, and if this is the final momentum before after collision, then it should be equal according to conservation principle. And what is the total momentum before collision? It is MA UA plus MB UB. It should be equal to MA VA plus MB and VB. Am I right? Yes, it should be equal. Actually, this is the law of conservation and of linear momentum. The whole momentum before collision and after collision should be same. That is, before action, after other action, it should be same. There are a number of applications, my dear students. It is based on this particular conservation. Okay, like you have studied in standard 9th, that is the recoil velocity of gun. If you fire a bullet from the gun, then gun get recoil. If you are having the value of all the masses, that is the mass of bullet and gun, and the velocity with which the bullet fire, then you can find with which speed it recoil, that is the gun recoil. I will include a here the clip that you can see for the application of conservation of momentum. My dear students, one and the second application, the propulsion of rocket. As rocket move up, it get upthrust by the fuel that is eject out from the rocket. That is the second thing. My dear students, here one numerical it is coming in my mind. I am going to discuss, and we will do number of numericals on the basis of this particular theory. Okay, so let me do that particular simple numerical. Here, the question: suppose a balloon, we are having the mass of the balloon, the total mass of the balloon, it is m. Okay, by any means or method, when it was moving up with certain velocity, okay, it is moving up. Here the gas start leaking. The gas from the balloon starts leaking. Okay, the gas actually it leaks with the rate of, suppose, m by t kg per second. This much amount of mass leak out from the balloon at every t second. Okay, then you have to find the force with which this balloon get as upthrust. Find force. Find force on balloon. This is our question. Okay, now how we will solve this question? So my dear student, we will use the conservation of linear momentum over here. After leaking out, my dear students, if the balloon is moving with certain velocity which is constant, suppose it is v, let us suppose, okay, we have to find the force. According to the second law, we know that the F is equals to dp by dt, okay, and it should be the conserve, that is the momentum. But here the mass is leaking out, that's why the conservation changing, and due to that this balloon getting upthrust. Here we can write dp, it is mv over dt, and the m out, sorry, m not constant actually. Remember, mass of the balloon is changing. If it is m leaking out, so we can write here the v is constant, then dm by dt, it is m. So if you are having the value of dm by dt, with which rate mass is leaking out per second, and the velocity with which it is moving with a constant velocity, so you can find out the force. Okay, so this one is the one type of question. There will be the number of question I will give you. After that, the pendulums are suspended, one block, it is the one bullet start embedding the pendulum, how much distance it cover, how high it will move. Okay, this type of question will be there, and we'll enjoy that. But before that, we have to finish all the questions concerned with the Newton's second law. Now, the application of conservation of linear momentum. Application of conservation of linear momentum. So my dear students, to understand the application of conservation of linear momentum, I am including here, I am going to give you, tag here a video clip that will enable you concept of application. The two application, it will be done over this clip. Okay student, so let's see that video clip.
After having studied the law of conservation of momentum, let's talk about its applications. When a gun is loaded with the bullet is fired. The bullet moves with a very high velocity. By Newton's third law, to every action there is equal and opposite reaction. Thus, gun recoils in the opposite direction. Since gun is much more massive than the bullet, it recoils back with very less velocity. Here, the mass of the gun is denoted by capital M, and mass of bullet is denoted by small m. As the gun is fired, the bullet moves forward with velocity of small v. As a result, the gun recoils back with velocity capital V. Now, according to the law of conservation of momentum, the total momentum before firing is equal to the total momentum after firing, that is, the initial momentum is equal to final momentum. Now, the initial momentum of the system is 0 because initially the gun and the bullet both were in a position of rest. Talking about the final momentum of the system after firing, so we can say it is equal to the momentum of bullet plus the momentum of the gun, that is small mv plus capital MV. Now if we rearrange the equation, we'll get the recoil velocity of the gun as minus mv upon capital M. Here the negative sign shows that the direction of recoil of gun is opposite to the direction of velocity of the bullet, so we can say the recoil velocity of bullet is opposite to the direction of motion of the bullet. The rocket works on the principle of law of conservation of momentum. The gases ejected from the nozzle gives a force upwards to the rocket. We can also apply law of conservation of momentum in case of rocket repulsion. If we ignore external forces, the momentum gained by the rocket in the forward direction is equal in magnitude the momentum of gases in the opposite direction. Thus the rocket and the exhaust gases push one another, and Newton's third law of motion is applicable in this case. Suppose the gases are ejected at a velocity of small v, and masses of fuel gases is denoted by small m. The mass of rocket is denoted by capital M, and it moves forward with the velocity of capital V. Now, according to the law of conservation of momentum, we know the initial momentum is equal to final momentum. Now initial momentum of rocket can be stated as mass into velocity, Initially the rocket was at rest, so its velocity was 0. So we can write the initial momentum of rocket is m into 0, that is 0. If we talk about the initial momentum of the fuel, initially the fuel was also at rest position. So we can say the mass into velocity of fuel, that is again 0, so initially momentum of fuel can be given as m into 0, that is again 0. If we talk about the initial momentum, that is total initial momentum, we can say it as sum of initial momentum of rocket plus initial momentum of fuel. The both are 0, so the total initial momentum is also 0. Now, final momentum of rocket when the velocity v is being acquired by the rocket. So we can say if we talk about the final momentum of rocket, we can say it as mass into final velocity of rocket, that is m into capital V. If we talk about final momentum of fuel, the mass of fuel is small m and velocity is small v. So final momentum of fuel can be given as mv. The total final momentum of the system, now it's given by sum of final momentum of rocket and final momentum of fuel, so we can say the total final momentum is equal to mv plus small mv, which gives us the total final momentum of the system. Now, if we equate, or if we substitute the values of total initial momentum and final momentum in this expression, we can say the initial momentum is equal to the total final momentum. If we rewrite the equation by more simplifying it, we can write, the velocity of rocket that we denoted by capital V is equal to minus of small mv upon capital M. Here this negative sign denotes that the direction of velocity of rocket is opposite to the direction of motion of gas, so this is same the expression that we have already derived in case of motion of gun, or say required velocity of gun.
My dear students, I hope that you enjoy that video clip and you got the concept of the application, okay, how the application did. Now my dear students, we are going to discuss here the man in lift, okay, the case of man in elevator or lift. Let me run this. Man in lift. As we go inside elevator, what we perceive, actually we feel some change in our weight, Either we feel our weight get increased or decreased. Why it happen? Actually, the weight we feel, it is appeared by us, it has been increased or decreased. In fact, we are having the same weight, it has been not changed. But why we appear? So we appear, it is due to the motion of lift. If lift is in a static state and you have kept a weighing machine inside the lift and you see the weighing machine, you will find the exact measurement of your weight as well mass. But as the lift goes up or down, you will see there will be changes in reading of weighing machine. It is due to the relative motion. Okay, due to the motion of the lift. We are going to discuss what will happen if lift is going up, what will happen if lift is going down, and what will happen, my dear students, if lift freely falling. It quite be very dangerous. Now, you all have encountered with the situation when you sit inside giant wheel. Okay, when giant wheel goes up, we enjoy a lot. Yes, it gives us the pleasure, but at the same moment when the giant wheel goes down, what we feel that someone keeps up, hold up, and just leave freely to fall, and we get scared. Yes, what will happen? Okay, it's very scary. Now we are going to discuss the man in lift. Here, this is the lift, that is the elevator. It is connected with the rope and it goes over the pulley or the mechanism. We are not going to discuss over here of the elevator. Here inside the lift, mode is standing. Yes, that's very happy. Taklu is standing inside the elevator. What is the weight? As we have studied in standard 9th also, we have to study actually in standard 9th only. What is the weight? Weight is not the product of mass and acceleration due to gravity only, my dear students. Listen carefully. If the spin, it is freely falling, so you can say there is G acting, no doubt. But the calculative weight you will find here the zero. If you will keep this pen over the weighing machine, stick with the weighing machine and leave both weighing machine and this pen to fall down, you will see there is no reading over the weighing machine of this pen. What does it mean? The weight is zero. No, actually that weighing machine is measuring the value zero. Why it happened? So we, for the calculative, that is the measurement value, we can consider the weight as the normal reaction applied by the surface. If there is no normal reaction acting, then there will be no weight. If n 0, the weight will be 0. So try to understand and try to recall this one, memorize this one. The weight is nothing but the normal reaction applied by the surface. Who is measuring the weight? Okay, I need this pen to be held over my hand to measure the weight of this pen. So it is the normal reaction applied by my hand. If it is more heavier, then I'll apply more force as a normal reaction. So weight is the normal reaction. Okay, now discuss to this taklu. It is inside the elevator. The weight of this taklu, it is acting how much? Suppose mg. Here m is the mass of man inside the elevator. Okay, now if that particular man applying the force as the weight over the elevator, then elevator will also apply some force, and it is using the two legs, it will be the normal reaction. Actually we are saying this n as the apparent weight, or you can say weight of the man inside the lift. Here the lift is in rest. Alright, that is the V is 0. Of course the acceleration is 0. Now we can write using the equation, the Newton first law, what will happen? The n sigma Fy equals to 0, and this n can be written as equals to mg. So this is the actual weight of the man when all the things are in hand, the lift is not moving. Now case 1. Remember, on the basis of this particular topic, you have to solve the questions which is in NCERT, and it is given in my assignment also. Okay, so here, now the lift, this is the man, and the lift is going up with an acceleration a which is less than z. What will happen? Try to calculate all the forces. Again, here the weight of this person, the normal reaction, it is n, although this lift is moving up. Now we will apply the Newton's second law. Remember, now this lift is not in rest, so you don't have to apply the Newton's first law. We'll apply the Newton's second law. If this is our positive y-axis in which we are starting the motion, now the sigma Fy can be written as mass times acceleration. Okay, we are considering all the things for the man. Remember, not the elevator. We are not taking here the mass of the elevator. We are taking the mass of the man inside the lift. Ma sigma Fy, it is moving up, so it is the positive n minus mg is equals to ma. Now you can see here that n equals to ma plus mg. Now here the weight is being increased as the lift is going up. What will happen? There will be the smile on the face of this Taklu. Yes, it is weight increase and it is moving up. He will enjoy. Now the second case, as lift is going down. Case 2. Here lift moving up, lift moving down, okay, with an acceleration less than z. Again this lift, Taklu inside the lift, we don't know whether this Taklu is happy or not, but this lift is going with an acceleration a downward. We'll get here the mg and the normal reaction. Okay, the normal reaction from the Taklu, that is by the lift. We take our axis positive and negative here in this direction. Now what we'll write? Again we'll write sigma Fy is equals to, it is m times a. Now here the downward force is the positive mg minus the upward force, it is the n, is equals to ma. So n will be mg minus ma. Suppose a is 0, then n will be the mg, but the lift is moving. The faster the lift will moving, faster this n will decrease. Okay, and this n is nothing but the apparent weight. Okay, this n is the apparent weight. The faster the value ma will decrease, the faster will be the apparent weight will be decreased. Okay, so now this apparent weight is being decreased by which amount? This is the ma. Now if the weight is suddenly decreasing, the Taklu will be not happy, of course. Okay, as in tension. Now what will happen? We are going to increase this tension. Now lift is going to free fall. Case 3. Taklu inside the lift, mg, the case, free fall of lift. Okay, that is, it will move down, of course, with which acceleration? It is equals to z. If it is freely falling, then the acceleration will be equals the acceleration due to gravity. Now it is the normal. Okay, again we will write sigma Fy, it is equals to ma here. Okay, now sigma Fy, the total force, it is moving down. We can take the positive axis x and y. Here the mg minus n, it is equals to ma, but the value of a, we know that it is equals to z. So we'll write here the n equals to mg minus mg, which is equals to 0. Apparent weight is 0. Now the stuck glue is in very soft. Okay, where my weight gone? So it is the case of weightlessness. Okay, so in this case, student, we have studied. One of my students had discussed, I don't know exactly, I don't remember the exactly year, but what will happen, sir, if this lift goes down with an acceleration greater than the acceleration due to gravity? Yes, you can also ask, if this lift is moving down with an acceleration greater than acceleration due to gravity, or if this lift is going up with an acceleration which is greater than acceleration due to gravity. So I'm leaving this particular question before you. You can just get the discussion with yourself, with your friend, and if you'll get particular conclusion, kindly let me know. Okay, so this was the cases of man in lift. We are left with few minutes more, my dear students, so let me discuss one concept, and then after we'll conclude today's lecture, and we'll start the next lecture with some numerical which has been asked in competition. Okay, so here the one question as example. On inclined plane, if the angle of inclination it is theta on the base, if a block of mass m is kept, what will be the acceleration of the block? You have to find the acceleration. I know the number of students are eager to solve this question, and you can. Okay, that's my pleasure, my dear students. But let me discuss here for all comments, and then I will give you a question. Here, as you know that I have discussed, first you have to make here the plus sign for the free body diagram. It is mz, and this will be the theta. This is mz cos theta, and this is mg sin theta. Remember, there is no friction between the block and the wedge we are considering. Here we will study that topic also in friction chapter. But here we place a block over the wedge and we left it. It will start moving. Okay, you have to find the acceleration with which it is moving down. You can see, my dear students, you have to apply the Newton's second law. Suppose this is the positive axis, x and y. What we will write? Sigma f x is equals to 0, or sigma f x equals to max. Yes, here the normal reaction we can. Now we have to write the sigma fx equals to max. Remember, why? The system is not in equilibrium, it is moving. Unbalanced force is acting to bring this block down. So the sigma fx, only one force is acting over the x-axis, and it is the mg sin theta. It is mg sin theta, which is equals to ma. Very simple, the m will be cancelled out. So a, it is z sin theta. Kindly remember this acceleration, my dear students. This is very, very important. Whenever you keep any object of any mass, m, 2m, 5m, 10 kg, 5 kg, 3 kg, and whatever may be the angle, block will move down, the slide down, if the friction is not there, with an acceleration of g sin theta. You have to remember this one, g sin theta, g sin theta over the inclined plane. We'll use directly this value g sin theta whenever we will do the questions of inclined plane. Okay, this one. Now, homework. my dear students, I hope you got this one. Next day we will do some questions on the basis of this inclined plane whiz. Okay. First we will do the question of R level, that is the school level, and then we will move for the competitive question. Here, my dear students, the question I am leaving for you. This is the homework. I will write with the black pen. It is homework. I have not given much homework today. Here the two ways are there. Here the 37-degree, a block of mass 2 kg, it is kept alright, this much, and the height I will taken here the 10 meter. Alright, it is 10 meter. Now I've left this block from initial velocity 0. It goes down and leave the wedge in t1 second. Now you have to find this t, the 10 meter 2 kg block, 37-degree inclination. It leaves the wedge in t1 second. You have to find the t second. You have to find the time. Now the second question, which is very important, look at here, the two ways. Suppose here theta 1, mass m, I've left from initial velocity 0, there is no friction, and in second case I have left this mass theta 2, okay, again with the same point, okay, and with the initial velocity 0. In which case the body, that is the block, will reach the ground first. If this is the ground, in which case block will reach the ground first. You have to find in this case or in this case. The condition is theta 1 is less than theta 2, the first condition, and the second condition, the length of this inclined plane that block has to move in both the cases are same, while the inclination is changed. So you have to find in which case the body will reach the ground first, and what should be the condition we left this block to reach the ground first in our case. Okay, what will be the condition this block will reach the ground in our case, in any case. Okay, so this is all about today's lecture, my dear students. We'll come to the next lecture and we'll study and we'll solve few more questions on the basis of this Newton's second law. Okay, my dear students, thank you very much.